Here's another example of graphing a quadratic equation, and this one now is in vertex form. So this is going to be a little different the way we approach it, but we get the same results. So this is in vertex form. All right, and this is negative x plus 2 squared plus 6. And now since this is negative, we know it's going to be shaped like an N, so we can just say that it's open down. So that's easy. And we want to find the vertex, and since it's in vertex form, we've got it right here so we can see the vertex. The vertex is going to be, remember, opposite sign, same sign, so it's going to be negative 2, 6. So our axis of symmetry is going to be easy because this is the x and this is the y. So our axis of symmetry is going to be x equals negative 2. And the maximum minimum, well, since it's shaped like an N, it's going to have a maximum, so circle maximum, and that maximum is just going to be the y value at the vertex, or 6. So that's easier, okay? We also know we have a shape equation. My shape equation is going to be y equals negative x squared, negative. That means if you look at shape values, I'm going to go over 1 down, 1 over 2 down 4 rather than up. So that's going to be easy to figure out. Now we have to find the y-intercepts. Now this is a little bit different. All right, so my y-intercepts are going to be over here. I'll do this over here. Remember the y-intercept, that means the x is 0. And we have a value for y. So if I put 0 in here, I have y equals negative 0 plus 2 squared plus 6. So every time I see an x, I put a 0. And then that's going to equal negative, and that's just going to be 2 squared, which is 4, negative 4. Plus 6, and that's just going to be equal to 2. So that's my y-intercept. So my y-intercept is going to be 2. Okay? All right, I hope that makes sense. So my y-intercept is 2. Okay, now I've got to find the x-intercepts. And it's a little bit different, so we can go over here, we can write the equation down. And remember, the x-intercepts will be where y is 0. So this is your xy. And the y-intercepts are where x is 0, so I can put a 0 in here. I'm sorry, the 0 for y, so the x-intercepts will be where y is 0. And I want to find the x value. So now we can write our equation. Y equals negative x plus 2 squared plus 6, and we want the y to be 0, so we'll just set that equal to 0 and solve it. So it's a quadratic equation. So we can subtract 6 from both sides. So we got x plus 2 squared with a minus equals negative 6. Then if I divide both sides by a negative, I've got x plus 2 squared equals positive 6. And we've done some problems like these. Now I know that if something squared equals 6, then that something, x plus 2, equals plus or minus the square root of 6. All right? So my values would be either x equals, and if I subtract 2 from both sides, x equals minus 2 plus or minus the square root of 6. So now I got two values, either x equals negative 2 plus the square root of 6, or x equals negative 2 minus the square root of 6. All right, so this is where it gets fun, because what's the square root of 6? So we talked about this before. We do a kind of interpolating. We know that the square root of 4 equals 2, and the square root of 9 equals 3. So how can we find the square root of 6? We know it's somewhere in between, so we can write the square root of 5, square root of 6, square root of 7, square root of 8, and if we approximate those are going to be approximately, but since it's between, it's going to be approximately 2.2, 2.4, 2.6, 2.8, and 3. So notice how that's a nice even spread. So we can say approximately, the square root of 6 would be approximately 2.4. So I can use that for a value. So I'll do that. So I can say that x will be approximately equal to -2 plus 2.4, or approximately -2 minus 2.4. And that's going to be 2.4 minus 2 is 0.4. And that's going to be -4.4. All right? So those are my x-intercepts. 0.4 or -4.4. So those are my x-intercepts. So those are a little tricky. Now sometimes you can just leave it in radical form. If you have to write the radical form and leave it like that, that's going to be fine. But when we want to graph it, it's going to be a little harder. Okay, now we want to graph this. So we've got a lot of points here. So first of all, our vertex is at -2, 6. So -2 up 6, so there's my vertex. Now I can use my shape equation also. And remember, if we had our shape equation, then that's going to be next negative x squared. So if I got 0, 1, -1, 2, -2, remember this. All right, this is going to be my vertex 0, 0. Then I'm going to go over 1, and it's going to be down 1, back 1, down 1, over 2, down 4, back 2, down 4. So that's going to be my shape equation from here. Now, that's not going to be the points on my parabola we're going to fill in over here, but that's going to be the points relative to this. So we can actually see that we're going to go over this way, that way. So you can work that out, and you could also check the intercept. So let's do it this way first. Let's put the y-intercept in. So that's going to be the point 0, 2. So 0 out, 2 up. Now my axis of symmetry is over here, so I can write the axis of symmetry again. So there's your axis of symmetry, so I know I got a point on the other side of that. But this is 2 to the right, I got 1, 2 to the left. And then my intercepts are going to be 0.4, well that's a little less than a half. 0, oops, should be over here, a little less than a half. And -4.4, 1, 2, 3, 4, and a little less than half there. So there's some good points. And now if we use our, if we even use our shape equation, we've got the point, we go over 1, down 1, back 1, down 1, and we go over 2, down 4, 1, 2, 3, 4. Well, that's our intercept. So we actually have those points again. Over 2, down 4, back 2, down 4. So our shape equation is consistent. So we got all kinds of points on this parabola. And here we go. So you can graph this. And there you go. So that's all you need to do. So take a look at that and think about it. Now we wanted some points here, and we usually put our vertex in. So this is the vertex. And that was the point -2, 6. And if we use these points over here, I've got my y-intercept. So my y-intercept is going to be 0, 2. So x is 0. Y is 2. And I had this other point over here. And this point was the point, the symmetrical point, which was going to be -4. So I could write that symmetrical point, which is -4, 2. And then I had the point 0, 2, which is my y-intercept. Okay, and you can see how these are going symmetrical. And then I'll use my x-intercepts. I won't use my shape equation. Dad, I'll just use my x-intercepts because I actually had to find them. So it'd be kind of nice to use them. So this is -4.4 and 0. And this is 0.4 and 0. And these are the x-intercepts. And this is the Y-intercept over here. And I guess I should put that with the symmetric point in blue. And that's the Y-intercept. And this is its symmetrical point. And notice how, again, you see the symmetry here around the Y value, because these things are very symmetrical. Okay. So there's another one. Oh, we haven't done domain and range. Excuse me. Remember, the domain is negative infinity always. Negative infinity to positive infinity always, I should say. Now the range, notice I'm going down here to negative infinity, so this is going to look like this part, because it's going down towards negative infinity. And it's going up to my maximum value, which is 6. And that's a bracket. So there's your domain and range. Okay, so take a look at that. We'll give you a couple of other ones to practice. And I might put those up just a little bit later, so be looking for those. A couple practice problems, but this should give you a good idea of what's going on, all right? And then we'll have a couple that you can practice on shortly. Okay? That helps.